It's a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have
3-ATLAS entered our solar system as a mystery, glowing strangely and moving in ways no one could explain. Now scientists have uncovered its true identity, and the truth is bad. This is not a simple comet, not a harmless rock. What they found may be the most unsettling space discovery in years. The finding of 3-ATLAS was a unique event in the field of astronomy. It was discovered using the ATLAS, a system in Chile that scans the skies for any abnormal activity. Astronomers immediately recognized that 3-ATLAS was not a typical asteroid or comet found in our solar system. The initial hint about this mysterious object came from its orbit. Unlike typical comets or asteroids that follow the gravitational pull of our sun, this object had an unusually high orbital eccentricity. This detail strongly suggested to scientists that it was not under the influence of the sun's gravity and was not from our solar system. Instead, it was a genuine interstellar traveler moving through our solar system on a very unique path that set it apart from any other objects we have observed. This was a rare visitor, and it was moving at an incredibly fast pace on an extraordinary trajectory. The story became even more interesting when astronomers started studying it closely. The Hubble Space Telescope focused on this unusual object and started taking pictures. The images showed something unexpected. The object had a glow, but it was not like a typical glow. It had a unique and intense brightness pattern that made it different from familiar comets. Usually, scientists determine the size of objects in space by looking at how much sunlight they reflect. A stronger reflection usually indicates a larger surface area. When using this method to analyze 3-ATLAS, initial estimates indicated it would need to be nearly 20 kilometers wide to appear as bright as it did. This size is massive, almost 40 times larger than other interstellar visitors like Oumuamua or 2I/Borisov. If this estimate is accurate, it would make 3-ATLAS one of the biggest interstellar objects ever discovered by humans.
Kilometers, twice as big as Manhattan Island, or maybe a dense cloud of dust. Now, until
Not everyone agreed with the explanation. Avi Loeb and Eric Kito noticed something interesting. The glow of 3-ATLAS did not seem like reflected sunlight. Instead, it looked like the object was producing its light. This discovery changed the way astronomers interpreted their observations. If the light came from inside the object, then the initial size guesses were incorrect. It may not be a 20-kilometer monster, but rather something smaller, possibly only a few hundred meters wide. The contrast between a massive giant and a reasonably small rock is significant. This was not just a small adjustment, it completely changed the way scientists interpreted the finding. This shift in size was significant for a different reason. The likelihood of discovering a 20-kilometer asteroid passing through our solar system is very low. According to Loeb's estimates, there are very few of these large rocks floating through the galaxy. A rock of this size might only come around once every 10,000 years or longer. Giant asteroids are not commonly found in interstellar space, so we don't see them regularly. However, if 3-ATLAS was smaller and glowing independently, then the situation would be different. The chances of smaller objects appearing more frequently made sense. The idea of a self-illuminating object led to new possibilities and pushed the boundaries of what astronomers believed could exist in space. The main question was, how does an object produce its light, the strange glow? When astronomers initially observed the dim yet constant light emitting from the interstellar object called 3-ATLAS, they were presented with an unexpected puzzle. Initially, they considered the possibility that the light was caused by radioactive decay. Theoretically, radioactive substances can emit light as they disintegrate, releasing energy into space. However, there was a major issue. The odds of locating a sufficient amount of radioactive material freely floating in interstellar space are extremely low. The universe is immense and mostly void of matter, and radioactive substances rarely accumulate in large quantities outside of planetary systems. This made the proposed explanation seem highly unlikely. Another reason for the brightness could be that the light was coming from heat originating deep within the object. Thermal emission occurs when an object produces heat internally and then emits it outward. However, there was a challenge. In order for this illumination to be visible, the inner temperature of 3-ATLAS would have to remain much higher than what solar heating alone could sustain. Space is cold, and objects in space typically do not retain much warmth. To continue glowing, this object would require a cause of heat beyond the usual natural sources available. And then there was the exciting idea to consider, what if the glow was not natural but made by advanced technology? This concept intrigued everyone. The idea of artificial light coming from an alien object in space was both exciting and unsettling. Could this object be more than just a rock or ice? Is it possible that it is a probe or spacecraft created by beings from another planet? Scientists looked at observations to find answers. Data from Gemini South and NASA's infrared telescope showed something interesting. The surface of 3I/ATLAS had water ice, along with carbon-rich minerals and silicates. The water on this comet was unique. Unlike the water found on most comets in our solar system, it seemed to be pure and untouched by heavy isotopes, indicating that it may have originated from a different star system billions of years ago. What astronomers were observing provided a direct insight into the ancient materials that make up planets from other parts of the galaxy.
Back behind the object by the solar radiation pressure. And so one had to conclude that perhaps...
Despite these discoveries, the mystery continued to intrigue scientists. Some believed that the clean water affirmed the theory of a natural comet. However, others noted that it could also fit the idea of an artificial object. If 3I/ATLAS was indeed a probe, it might have gathered dust, ice, and other space debris while traveling through the universe for millions or billions of years. For a time, this accumulation could have disguised an artificial object as a typical comet to the casual observer. The argument became more intense as scientists examined the path of 3I/ATLAS as it moved through the solar system. The trajectory of the comet was surprising because it was moving in a retrograde orbit, unlike most planets. However, its tilt was only slightly off from the plane where Earth and the other planets orbit. The odds of this alignment occurring randomly were very slim, calculated at only 0.2%. Researchers were surprised when they looked at the future encounters of 2I/Borisov. The comet is going to pass very close to several planets. It will get within 29 million kilometers of Mars on October 3rd. Then on October 29th, it will come closest to the Sun at 1.35 astronomical units. After that, it will go within 33 million kilometers of Jupiter. The chances of a random interstellar object getting this near to 3 major planets on one trip are about 1 in 20,000. These odds are so small that it brings up serious questions. Is this just a coincidence, or is there something more intentional going on? Then came the weirdest part of all. When 3I/ATLAS is closest to the Sun, Earth will be on the other side of the star. This means we won't be able to see the object during this important time. The Sun's glare will block our view completely. Some people thought this timing was almost too perfect. If someone wanted to create a spacecraft that could move without being seen, this would be the perfect scenario. Some scientists started to speculate about whether the spacecraft 3I/ATLAS might be using a method called a reverse solar Oberth maneuver. In basic terms, this would mean using strong propulsion to decelerate near the Sun, enabling the spacecraft to slow down and possibly stay within our solar system. The fact that all of this would occur while Earth's perspective was blocked by the Sun's brightness added to the mystery. Was it simply a fortunate coincidence? Or was it a sign of deliberate planning? Although the concepts are intriguing, most astronomers are hesitant to fully embrace them. Many still think that 3I/ATLAS is just a typical comet from outer space. This belief is based on solid evidence. Expert David Jewett, who specializes in comets at UCLA, has examined data from the Hubble Space Telescope and observed that the object displays characteristics typical of a comet. The amount of dust it emits, estimated at 6 to 60 kilograms per second, aligns with what is typically seen in other comets. Additionally, the speeds at which materials are expelled, ranging from 20 to 2,000 meters per second, fall within the expected range. One more thing to consider is the absence of certain gases being detected. Astronomers have not found volatile gases such as cyanogen or diatomic carbon near 3I/ATLAS. However, this is not surprising. The object is still far from the Sun, around 4 astronomical units away, similar to Jupiter's distance. Comets often do not emit strong gases until they are closer to the Sun, where the heat can activate their frozen cores. The shining mystery. The concept of 3I/ATLAS possibly emitting light alone is intriguing and confusing. Scientists refer to this as the self-illumination hypothesis. However, this idea presents significant obstacles. For an object floating through space to produce its luminosity, it would have to generate a substantial amount of energy. The calculations indicate it would require about 10 gigawatts of power. To give some perspective, this is the amount of energy produced by multiple large power plants on Earth. Now picture an object that can hold on to a huge amount of energy for millions of years as it travels between stars. This would be extremely challenging unless it had an immense fuel supply or advanced technology beyond our understanding. The concept of self-illumination is hard to believe, but also adds to the intrigue of the mystery. Currently, the world is at a crucial moment in time. The spacecraft ITLAS is approaching the Sun, which is a significant part of its mission. If it is indeed a comet, as it gets warmer from the Sun's rays, it should start giving off gas and dust. This would result in a typical cometary tail forming, indicating that its brightness is from sunlight reflecting off the material being released. If these emissions are visible, it would clarify the reason for the glowing. However, if nothing is observed, the mystery becomes even more perplexing. Astronomers are using the most advanced tools to closely observe the object, known as 3I-TLAS. The James Webb Space Telescope is currently focused on this object, using infrared light to learn more about its temperature and energy emissions. Scientists hope that the sharp vision of the Webb telescope will reveal new details about this interstellar visitor that we have never seen before. Another perspective may be available from Mars soon. In early October, 3I-TLAS will approach Mars closely enough for the Mars Reconnaissance Orbiter to potentially take pictures. The Mars Reconnaissance Orbiter is equipped with a strong camera that can capture detailed images. If successful, these images could be the most clear close-up photos ever captured of an interstellar object. With these images, scientists could determine if the light we see is from sunlight reflecting off its surface or if it is emitting light alone. But the fun doesn't stop there. A new observatory, the Vera C. Rubin Observatory, has recently begun operating. This is no ordinary telescope. It is an innovative facility built to carefully observe the night sky. It will have the capability to identify numerous interstellar objects annually. This indicates that scientists will have a greater number of objects to analyze instead of just a few mysterious visitors like Oumuamua and 3I-TLAS. Having more instances to study will make it simpler to distinguish between typical and uncommon behaviors for these objects. Imagine if the self-illumination theory turned out to be true. It would suggest that 3I-TLAS is not only shining alone, but also traveling on a planned route through our solar system. This discovery would be significant evidence of another advanced civilization coming to Earth. The impact of this realization would be monumental, altering the course of human history. It would confirm that we are not the only beings in the universe, and that we are witnessing signs of advanced technology from a distant place. Even if 3I-TLAS ends up being a normal object, it is already revealing something significant to us. Its peculiar brightness and strange actions demonstrate that objects from other star systems can amaze us in unexpected ways. Perhaps there are natural phenomena that we have yet to comprehend. Alternatively, there could be scientific principles that behave uniquely in the vastness of space between stars. Regardless of the reason, this particular visitor is compelling us to broaden our perspective on what can occur in the universe. Where are we now? The spacecraft from 3I-TLAS is still moving through our solar system, and astronomers are collecting more information every day. The upcoming months are crucial. In October, the spacecraft will get close to Mars, providing a unique opportunity to capture images from another planet. After that, it will approach the Sun, and by December, it will come close to Earth. These events present chances to discover new insights. The responses can help us determine if the glow is natural or supernatural. They can indicate if the object is a comet, an asteroid, or possibly something even more unusual, the silent red visitor from the stars. When scientists pointed Japan's CME telescope at the unusual interstellar visitor 3I-TLAS, they found something astonishing. The telescope showed that this object looks very red in visible light. Its color is similar to the dark D-type asteroids commonly seen in the outer regions of our solar system. What's more, 3I-TLAS may be even redder than these asteroids, giving it a special and mysterious glow. Astronomers closely examined the brightness of an interstellar object on July 15th. They wanted to see if there were any small changes that could indicate if it was spinning fast or had sudden bursts of activity. However, they did not observe any immediate changes. The reflected light remained constant, indicating that it may be rotating slowly or just have a stable outer layer known as a coma. This consistent glow provided more insight into the mysterious nature of the object. It was even more surprising that no gas emissions were detected during that time. Normally, comets that pass near a star show activity as heat causes ice and gas to escape, creating tails of vapor and dust, making them look bright and active. However, Comet 3-ATLAS did not show any clear signs of this outgassing. It stayed calm without any jets or streams commonly seen in active comets. The results of this study, when put together with previous research, show an interesting picture. Earlier studies indicated that 3I/ATLAS did not have much water ice and had very little gas activity. With each new observation, it became more apparent that this object from another star system was different from a usual comet. It appeared to be more like a rocky object with a surface that had a lot of dark reddish material. This finding sets 3I/ATLAS apart even further. If it is indeed similar to a D-type asteroid, then it is not just a typical comet made of ice and dust. Instead, it is a space rock from another star system, probably coated in materials rich in organics that make it appear deep red. It might not be very active, emitting only minimal gas, which could clarify why experts have not observed significant movement or sudden brightness variations around it.